Hello and welcome to another Algebra 1 video tutorial. In lesson 1010 we'll be looking at nonlinear systems. So our goal will be to apply the techniques of the chapter to the solution of systems in which at least one equation is not linear. So far up to this section we've been looking at two lines and maybe where they intersect for a solution of the system. Now we're going to have where one of them is not a line. Okay, so the idea is used to solve systems of linear equations can be applied to solve some systems of nonlinear equations. Let me draw you a little rough sketch of what we're talking about here. So let's say we have one equation is a line and another one is like a parabola. So we're looking for a quadratic, and the shape of the graph is a parabola. We'll be looking for these two solutions. Something such as this. Okay, so that's what we're going to be looking for. So solve the system y equals negative 2x squared plus 3 and y equals x plus 3. Now this is set up for graphing. You could graph and find the intersection. I'll show you what that looks like in a minute. But this is also set up to use substitution. So let's use substitution. So since they're both y equals, I could use substitution and say, all right, negative 2x squared plus 3. So I'll substitute what y is here in for this y equals x plus 3. Now we have a quadratic because we have an x squared term and an x term, so I would probably subtract x and subtract 3, so I'd end up with negative 2x squared minus x, and then we have a 3 here and minus 3 from both sides, we end up with equals 0. So we can use quad form program, or we can do this by hand pretty quickly. So our a value is negative 2, our b value is negative 1, and our c value is 0. First find the discriminant to see how many solutions there's going to be. So it'll be the opposite of 1 squared, or negative 1 squared. So b squared minus 4 times a times c. And that makes a pretty easy calculation. There it's going to be 1 minus 0, so just 1. So that means it's a positive, so there's two solutions. So we're going to get the opposite of b, so 1 plus or minus the square root of our discriminant, which is also 1, all over 2a. So 2 times negative 2 is negative 4. So for one solution, and this is what x is going to equal, 1 plus 1 is 2. 2 over negative 4 is negative a half. Or 1 minus 1 is 0. 0 divided by negative 4 is also 0. So those will be our two solutions for x. Figure out what the y is accordingly. So in the first one, I'm going to put in negative 1/2. Negative 1/2 plus 3 is 2.5. So one of my solutions is negative 1/2 and 2.5. The other solution was 0. Is going to be 0 plus 3 is 3. So it's going to be 0, 3. Okay, if you graph this, here's what your graph would look like. And you'd be looking for this intersection point right there. And this intersection right there is our solutions. This one should be negative 1/2 and 2.5, and this one here should be 0, 3, which matches up with our work we did by hand. Okay. All right, another one. Solve the system. Y equals 2x plus 1 and y equals x squared plus 7x plus 5. So once again, set up for substitution or graphing. I will show you what the graph picture looks like after we solve this by hand, because substitution is set up nicely for this. So I'd say 2x plus 1 equals x squared plus 7x plus 5. I would probably subtract 2x and subtract 1 to get this equal to 0. So I have x squared. Now I had 7x and I subtracted 2x, so that becomes 5x. Had 5 and I subtracted 1 from both sides, so that's plus 4. Let's find the discriminant. So I'm going to go b squared minus 4 times a times c. So that's going to be 25 minus 16. 25 minus 16 is 9. So that's going to mean there's going to be two solutions. So we want x is going to be the opposite of b, and b was 5, so negative 5. Plus or minus the square root of our discriminant, b squared minus 4ac, which would be 3, all over 2a. A was 1, so that would be over 2. So for one of them, it's going to be negative 5 plus 3. That's going to be negative 2. Negative 2 over 2 is negative 1. And negative 5 minus 3 is negative 8. Negative 8 divided by 2 is negative 4. Okay, so then we've got to figure out what the y is to match up with that accordingly. And that's going to be, we could say 2 times negative 1. So negative 2 plus 1 is negative 1. So one solution is negative 1, negative 1. And the other one's going to be negative 4. 2 times negative 4 is negative 8. Plus 1 is negative 7. Okay, so there's the two solutions to this system. So -1, -1, that appears to be that intersection there. And -4, -7 appears to be that solution right there. Okay, so you would graph these and put in y1 and y2, find the right window, and then find the intersection if you don't feel comfortable solving those by hand. Okay. Number 3, solve the system y equals -x squared plus 10x minus 27 and y equals 0.1x plus 3. This one, they're set up for graphing or substitution, once again, just like the first two examples. So I'm going to use substitution. -x squared plus 10x minus 27. So I'm taking what y is here and replacing it down here in this y equals 0.1x plus 3. So I would subtract 0.1x and I would subtract 3, so I'm going to end up with -x squared. 10x minus 0.1x, that's going to be 9.9x. And then 27 minus 3 would be a minus 30, and now it equals 0. Have a quadratic. You can use quad form program that we developed in last chapter, or we can just solve this by hand. Let's find the discriminant first. So we're going to go b squared 9.9 squared minus 4 times a times c, and let's see what that ends up giving us, -21.99. And that's a negative discriminant, which means there is no solution to this system. It doesn't work. So what's that look like on a graph? Well, the bottom equation is the red one. This right here, we just get a line, 0.1x plus 3. And the top one is a parabola, but they do not intersect. There is no x and y coordinates that will work for one and the other, so there's no solution to this system. All right, number 4. The population of a town is 30 grand and has an annual growth rate of 1.7%. The population of another town is 28,000 and has an annual growth rate of 2.5%. Approximately how many years will pass before the towns have equal populations, and what will their populations be at that time to the nearest 1,000? So we have an estimate. Well, first we need a system of equations. So the population for a town, so let's just say population equals, now this is exponential growth. Something's growing by a percentage, that is exponential growth. So the beginning amount is 30,000 times the growth rate, 1.7%, so it's going to be 1 plus that, 100% plus, so 1.017, and then to the x power for the number of years. Okay, the other population is going to be beginning amount 28,000, and its growth factor is 2.5%, so it would be 1.025 to the x power. Now at this point in your Algebra 1 career, or up in your math career at this point, we don't have methods to solve exponential growth equations, so substitution would not work here. We'd just take this equal to this, and we don't have a method to do that. We need logarithms, which you'll learn in probably Algebra 2. Okay, so we need a graphical technique for this, so drag out your calculator if you want to follow along, and we'll graph these and find the intersection to get our estimate for the year, and then to the nearest 1,000 for population. All right, in your calculator, we'd go to y equals, and we would input the first equation, 30,000 times 1.017 to the x. y2, we'll put 28,000 times 1.025 to the x. And you'll need to get the right window here. So I know the beginning amount is 28,000 and 30,000, so I may go up to somewhere up to 50,000, count by 10,000s, okay? Now, I only went into the negatives here. I could probably start at 28,000, that's the lowest population value, but I started at -10 just to get the full amount here and see the x-axis. Okay, and then to see the y-axis, I'll go -1, and then I'm saying this is probably going to happen within 15 years. I might have to change that. So press graph. And here we have the population that started at 28,000 and then the one that started at 30,000. And we're looking for this intersection here. So we go to second trace, which is the calculate menu. We want to know where these two lines intersect, so option 5. And first curve is y1, press enter. Second curve is y2. And my estimate, where they're the same, pretty close in here, press enter. And intersection as when x is 8.8, so that's our years, so about 8.8 years, and y is about 34,800. So my answer would be about, maybe you'd even say 9 years, but about 8.8 years. And the population is, well, nearest 1,000 would be about 35,000. If we go nearest 100, about 38,000, 34,800 people. All right, that wraps this up. Your assignment will be 1010, page 642, 2 through 18 evens. Thanks for watching, and we will see you next time.